Griffiths. He's the Vice President of Research at the Masdar Institute. He has 45 minutes for the discussion, and you can play it as you see it, Stephen, when you'd like to go to the floor for questions or not. Thanks very much.
Well, thank you very much. It's a pleasure to be here today, and thanks to all of you who are staying for this final session with us. So as you've heard, this is a very important topic, introduction of environmental technologies into commercial aviation. Today, aviation accounts for about 2% of global carbon emissions. As we know from our work with our partners in the airline industry, the fleets of aviation is going to double over the next 20 years perhaps. So as we see the fleet growing and we know that we have current level of carbon emissions, which we're going to want to reduce for environmental sustainability purposes, we're going to have to look at all the methods and means by which we can address the potential growth in emissions and look at our environment in a sustainable way. In order to do this, there's various ways in which we can approach this whole area of sustainability in aviation. We can look at the evolution of current technologies, that's one approach. We can look at operational measures, we can look at air traffic control, air traffic management, and we can also look at the new technologies. Technologies which are not wholly new but have to evolve further before they gain the level of commercial traction which we're looking for, and this would include, for instance, biofuels, which we're talking about on the panel today. So with me, we've got a very distinguished group of panelists I'd like to thank for joining us. To my immediate left, David Hess, the Executive Vice President and Chief Customer Officer for Aerospace at United Technologies Corporation. Next to David is John Swift, the Director of NATS Middle East. Mr. Darren Morgan is the Director of Sustainable Aviation Fuel Strategy for Boeing Commercial Airplanes. And Lyndon Koppel is the Head of Sustainability at Etihad Airways. So in our panel discussion today, I'm going to go through a few questions for each of our distinguished panelists, and they'll give you their comments and reflections. And then after we go through a round or two of these questions, we'll open the floor to the audience to ask our panelists questions you may have based on what you've heard from them. So I'd like to start off from the perspective of evolving into new levels of innovation, current technologies used in aircraft. I'm going to start with David Hess. So David, we know there's been quite a bit of news about what UTC is doing in its propulsion systems, some very exciting technology being developed. Can you tell us what you believe is the future of propulsion systems in commercial aviation? And in particular, how will that evolution impact the customer experience in flight? So I'll hand it to you, David.
It's probably the least electrifying answer you're going to hear today on a panel, but quite honestly, from our standpoint, the future of propulsion for aircraft propulsion looks much like the engines that we recently went into service with today. Traditional mechanical propulsion, if we compare to other alternate technologies that are being evaluated out there, such as electric, such as solar, such as other technologies. With the new generation of engines, in fact, the engine that we just entered revenue service with on the Airbus A320neo just this past month, it makes a dramatic step change in fuel efficiency. It's a 16% fuel efficiency improvement over last generation engines, and we think we can extend that another 2% within a 2-year period, and within 10 years that'll be extended from 16% to 25%. So we can see a lot of runway with the current technology of mechanical gas turbine engine propulsion. The 16% may not sound like a large number, but when you take a look at the implications that has with respect to the carbon footprint, I mean, it's actually quite dramatic. It's about 3,600 metric tons of carbon per aircraft per year that are eliminated when you introduce the next generation gear turbofan engine. And if you do the math on that, you take a look at the number of aircraft we're going to deliver over the next 10-year period, and over that period of time, it's about 160 million metric tons of carbon that will not be put into the atmosphere, and about 15 billion gallons of fuel that the airlines won't have to purchase for the aircraft. So again, as we look at that, as we look at the engine that we just introduced into service and what we think we can do to improve that engine over the next decade or two, we think that's going to be the engine of the future.
Thank you, David. That's very interesting. So, John, I'd like to move on to you. From the NATS perspective, we talked about the fact that sustainability and reducing the carbon footprint, it's not all about technology. It's about operational measures as well. And so, tell us a little bit about what NATS is doing, but also, after you do that, tell us how the aviation industry, from your perspective, can help us promote sustainability promotes the reduction in carbon emissions, looking at air traffic control and airspace management.
So it's interesting to hear about all the language we're using so far in the discussion is about future technologies, alternative technologies, and as David said, it's going to take some time for the new technologies to be throughout all the fleets. So we're still going to have a lot of legacy equipment around. So it's important to think about what we can do now. And from the air traffic operations, there is a difference that can be made now. And I think it's one of the areas where focus has been on aircraft and engines. And the air traffic service providers have got a responsibility to play their part as well. So whilst we have in the past as an industry been very much looking at making our operations more efficient, it's largely around just simply reducing delay and getting aircraft to and from A to B more efficiently whilst maintaining safety. But it's important to remember the environmental aspect of it as well, and that is an important benefit that needs to be captured whenever any change or improvement is made in the air traffic system. And there's a couple of areas in particular I'd like to pull out. One is the concept of continuous descent approaches. So instead of aircraft being positioned towards an airfield and regularly leveled off and vectored around the sky and leveled off again, that actually we position aircraft and we design the routes and the arrival routes for airports so that aircraft can continuously descend, which means that from the respect of there's less fuel used because you've got that no leveling off and no positioning at that one level. And also the aircraft can be maintained cleaner for longer in the approach, which means that there's less drag and therefore less noise. Because from the perspective of our neighbours and around airports, it's also the noise perspective is one of the things that people are probably becoming increasingly aware of at the moment, as well as the CO2. So encouraging more continuous descent approaches is one area that it's not a new technology, it's not a brand new technique, but it's not in use everywhere. So it's about designing those kind of approaches into arrivals at airports. And the second element is really about greater collaboration and cooperation and beyond borders to be able to collaborate. So in the UK, to manage the traffic arriving at London, traditionally the traffic, as anyone who's flown in will experience, you fly in, you go to the hold, you're in the hold for a period of time, and then you're positioned onto the final approach. That's because largely that traffic that's approaching, traditionally we've only been able to manage probably in the south and southeast and southwest sectors within 80 miles. So there's not an awful lot of time to do anything with it. So we've, over the last couple of years, we've developed a system where we will interface with our colleagues in Ireland, Belgium, the Netherlands and France to be able to pass messages to them so that traffic up to 350 miles away is being slowed down if necessary. Over the last 18 months that system has been in use, it's reduced holding times per aircraft by a minute. So a lot of people might say, well, a minute, so what? Well, a minute for every aircraft over that period of time. We believe we've saved the airlines about $2.5 million in terms of fuel. That's always the measure, is the terms of fuel, but then when you add that and you multiply that up in terms of emissions as well, I think it's a really important metric that needs to be taken into account. And those kind of cross-border collaboration examples are really, really relevant for this region, where most of the country's airspaces are relatively small and most problems need to be fixed in your neighbour's airspace as opposed to waiting until it gets into your own airspace.
Very interesting. Now, certainly the operational measures that you're working on, you're describing the key to seeing the levels of sustainability that we're trying to achieve in the industry. Darren, I'm going to move on to you, and now we're going to come into an area of technology which is quite interesting, at least I find it very interesting. As the Director of Sustainable Aviation Fuels in Boeing Commercial Airplanes, what is your view of the status of aviation biofuels development today, and what have we seen evolve in the past 2 years since our last time here at the Global Aerospace Summit in Abu Dhabi?
The status of aviation biofuels is nascent and going well, despite the fact that oil is at very low prices today. Our strategy at Boeing is on environment is encompassing the two previous speakers' topics as the core. Better airplanes, fly them more efficiently, we and others in the industry view that that is necessary but not sufficient, and so we have to change the fuels is the philosophy. Most people know that by now. But to do that, since we don't make biofuels, we're not in that industry, we decided to work in a coalition manner over the past 8 or 9 years with many people on the stage, many organizations on the stage, and many in the audience to cause those supply chains to exist where they didn't. The good news is that's starting to happen now in real significant ways. We're hopeful that by the end of the year, with the approval of a new tranche of fuel that is now in work, the research report is being written, it will be balloted at ASTM, hopefully by the end of the year. And when that is approved, there will be well over 1 billion US gallons, 4 billion liters of renewable jet fuel available. And airlines are in the process of ramping up to purchase that as soon as it's approved. There's a lot of them doing that right now at competitive prices depending on where you are in the world, even at the low price of jet fuel today for petroleum jet fuel. So the sort of the main news is, despite low oil prices, things are going along pretty well. I think the people that are serious about it, the entities that are serious about it, look at it long term. Of course, long term, if anybody can guess the price of oil, then you shouldn't be in this room. You should be living on your private island. And so the reality is, of course, we don't know where that's going. And so if you're making a long-term play for carbon reduction, if it's also directionally correct on economics, which it does appear that the biological fuels are, then that's a good bet. And that's kind of who's motivated today, or the people that are thinking long-term. If you're just looking at spot oil prices today, you're probably not too interested. But from our perspective, fortunately, like Etihad and many others in the room and outside are quite serious about it long term, and technology trajectories have been very, very good. We've had some favorable scientific breaks, technical breaks. To be honest, not that we necessarily knew that 8, 9 years ago when we started, but they played our way, and so things are going really well. The activities that we're doing here in the UAE with our partners Etihad, Masdar, Career and others are an example of that, and we'll talk about that. But to sum up, yeah, things are going really well.
So Darren, you set up the next question for Lyndon perfectly. Lyndon, Etihad Airways, of course, is a major global airline, working closely with many partners on this biofuel strategy that you're developing. What is your projection for when Etihad will routinely be using aviation biofuels in its own business on its commercial flights?
Thanks, Steve. I think we were probably asked that question 2 years ago, and I'm not sure I can give it any more clarity now. Now, that doesn't mean to say that we haven't made a lot of progress. I think there's lots of different initiatives that are going on around the world. We could probably have taken, or possibly taken, an easier route in terms of being able to invest in a facility that was going to produce fuel and set ourselves a target, knowing that we could probably meet it by investing in an existing facility, or a facility that's going to be retooled to be able to create biofuel. We've probably taken a kind of longer journey with absolutely kind of no shortcuts. We've started right from scratch to the point where we're looking at a plant that's never ever gone through any plant breeding, for example. So even if you say to me, well, tell me how many plants it will need to do a flight, we don't know, because we don't know how, even with some simple plant breeding technology, how much yield we can get from this plant. So we've kind of decided to start from scratch because we think it's good for the UAE, and it's also a potential system that will be able to be replicated in many areas. Maybe I'll just explain very briefly what it is. It's a system where you can grow a plant using salt water, no need for any fresh water, and it takes the nutrients and the salt water from fish farming communities, so it's a kind of integrated system. We talk about it a lot now in terms of food and fuel, as opposed to food or fuel, which is something that's that has been an issue in the past. The system, I say, has got a lot of work to do. We've made some really great progress. We launched the pilot facility yesterday, so we're really pleased with the progress that's been made. It will be important for us ultimately to get fuel onto our aircraft, absolutely, and of course that's what everybody in Etihad ultimately wants to see. But at the moment, it's about getting this concept right. It's about making sure that we can do it properly, that we'll ultimately end up with a mechanism that will be commercially viable. One of the big concerns, of course, is that we'd go a route that we could potentially end up spending on fuel than we spend now. But we want to make sure that we can do it in a way that we make sure absolutely that it can be viable and it can be replicated.
Thank you. So commercial viability is extremely important. So that leads me to a question back to David. As we think about next generation technologies, you see over and over again, something I'm very interested in when I see DARPA and NASA working on electrification of flight. Everyone's very keen on this. They want to know what's happening. From UTC perspective, what is the future of electrification of flight? How will the future be electrification, and to what extent? And what are the types of things that have to happen in order to make that future possible?
We kind of see that future of the electrification of flight as being so far out in the distance, quite honestly, we can't see it. We just don't see the power densities for battery technology being anywhere near where they would need to be to consider it for commercial transports. If you take, for example, we would need at least a 10-fold increase in power density of batteries to be able to even get a single aisle commercial transport off the ground. For example, that means if you've got a Tesla today, a Tesla automobile has a range of about 300 miles. With a tenfold improvement in that battery technology, you could, instead of driving the Tesla 300 miles, you could drive it 3,000 miles, which is about the distance from Abu Dhabi to Frankfurt. So just imagine having that magnitude of an improvement. I mean, this is Nobel Prize winning kind of advancements in battery technology. Even with that level of improvement, you would need a battery that's about half the weight of the airplane to get a A320 or a 737 off the ground. Forget about cruise, forget about flying 3,000 nautical miles to its destination. Just to take off, you would need a battery that's about half the weight of an airplane, again, assuming that you've got a 10-fold improvement in battery technology. So it's just so far off. If you look at the efficiency of propulsion systems today, if you look at just the power conversion coming out of jet fuel as compared to batteries, again, if you look at power coming out of jet fuel as compared to power coming out of a pound of batteries, it's about 100 to 1. So the magnitude of improvement that you would need to have in battery technology and power densities there is just enormous to be able to even consider it.
Is UTC working on, say, the hydraulics, for instance, getting that further electrified in planes?
We are. I mean, we understand that the system architectures very well. In fact, we're the ones that provide the electric system for the all-electric Boeing 787. So we understand we have the largest aircraft electric system business in the industry. So we understand the power requirements and the architectures of aircraft. So certainly there's ability to apply more electric architectures to aircraft today. 787 again is a very good example of that, with, you know, for the first time in commercial service having an electrically versus a pneumatically driven air conditioning system, with major elements of the hydraulic system that have been made more electric, as well as other elements of the airplane that were typically done pneumatically or hydraulically are done electrically in 787. So certainly there's application in terms of power conversion and distribution on the aircraft and performing functions on the aircraft, but in terms of using electric power as propulsion, again, we don't see it.
Interesting. So we evolve electrification toward, not in the propulsion sense, but more toward onboard operations of the plane itself.
Exactly.
The energy density is just not there yet, and it's not foreseen to come anytime soon. With coming back to John, so we know, look at technology, look at the evolution of the trends across many industries. We know there's fuels and there's energy, electrification and such, but there's also this challenge of systemic complexity and data analysis. And so there's a whole set of sciences now looking at how systems like the Aerospace management system, which are now looking at real-time management, are leveraging data analysis and the ability to look at systems real-time in order to improve efficiency. So what is your view of how data analysis and near real-time ability to monitor the Aerospace system is going to contribute to reducing carbon emissions and increasing our environmental sustainability in aviation?
So I think it's back to the sort of the comment attributed to Peter Drucker of what gets measured gets managed, and that's been a big lesson for us in terms of that, as well as managing efficiency, we had to look at environmental performance as a measure. And so as an organization, we sort of went, okay, that's the right thing to do, and then, okay, how? So we've had to develop a lot of systems to be able to measure the performance of every flight that operates in the UK. Actually has an environmental performance metric applied to it, and we score ourselves, and we have to report to our regulator on that performance, and that has really started to push us to just make sure that we explore every avenue to be able to drive some efficiency. So, as an example, I talked about the continuous descent approaches. Even though we had set it up that it was available for airlines to use, we identified 2 airlines operating very similar aircraft types. One was doing continuous descent approaches 80-85% of the time, and the other was doing it about 20-25% of the time. So we got them all together in a room and said, you know, I'm not pointing fingers, but you're very similar operators. What are you doing that you're not? And through that sort of having data to be able to drive a discussion that was very, very focused on real information, and having that collaborative approach, it actually allowed the operator to change his procedures, and we've now got 40,000 more. Since that event last year, 40,000 more approaches have been more efficient. We've done similar things with airlines, where an operator has had 2 different aircraft types, maybe a 340 or a 330, and we've seen vast differences in the performance, and been able to show them the evidence and make them, then they will go and look at how they can address that. But it's forced us to look at what sources of data are available, how do we collaborate more with the airlines and the airports to get access to the data, and it's wider than just the environmental benefits. We recognise that fully utilising the capability of big data, real-time modelling, starting to do some what-if scenario planning, it's really what's driving change. And it is, you know, again, a Heathrow example is, it allowed us to generate an additional landing slot last year, which was the first time in something like 20 years, just because we were really, really focused on analysing all the data and doing the modelling. And, you know, the capabilities are more accessible now, and it's that really not thinking about how we used to do things, really talking to the technology experts in the data processing to say, here's what our problem is, how can you help us fix it? And it's really driven a completely different focus in the organisation to make sure that we are measuring everything possible, and then really starting to look for those efficiencies.
Interesting. So as you monitor these aircraft flying around, and we know that eventually someday they'll be having increasing amounts of bioenergy produced or biofuels, come back to Darren, and we want to talk about now what we know is a very important initiative Boeing has going on with Etihad Airways, the Integrated Sustainable Energy Agricultural System, the CEAS, which is part of our Sustainable Bioenergy Research Consortium, which Mazars and Suits involved with the partners Boeing and Etihad as founders. So Darren, from your perspective, from your view within Boeing and from the aircraft manufacturer's view, how will the pilot facility just launched in Masdar City really contribute to developing this new generation of bioenergy, and where will it go after this initial pilot?
Sure. The point of that pilot is to prove the economic viability, as Lyndon talked about, prove the economic viability of the system. The really important element about that sort of a system is that it's not all about fuel. And that is the mistake that's been made by many in the bioenergy industry. And it's kind of an easy lesson to learn if you just looked at the petroleum industry. The petroleum industry's profit margins are not coming from fuel for the most part. They're coming from high-value specialty chemicals, commodities that come out of petroleum. And those things, you know, something that's, you know, this much of it is worth, 100 dirhams versus this much fuel is worth, 20 cents. That kind of a magnitude of value addition is in the petroleum industry today. That is how the bioeconomy is going to evolve. And the system that we're all working together on, this seawater energy and agriculture system at Masdar, is essentially taking that same concept and applying it towards solving some other problems while making fuel as almost an afterthought to a much larger value proposition. So the fuel, to use an aviation analogy that I like to use to describe this, the fuel are like the coach passengers, and the high value things that come out of the system that we're working on together, or any other bioeconomy system that is, I think, well designed, are the first class passengers. That's where your profit margin comes from. And that's, I think, the strength of what we're doing, combined with some, frankly, novel science around these extremophile plants and what is in them and what you can do with them. There's just some biology and technology that's going on there that people haven't figured out yet that we have. And we're going to work on that together, combined in this sort of holistic business model. It's not just fuel, it's other things. And our success is going to come from that.
And so to take off on that response back to Lyndon, so for Etihad Airways and other UAE airlines, why are sustainable practices such as the Sustainable Energy Research Consortium, which you're a member company, why is this so important for your airline and others in this country? What's the value driver?
I mean, there's kind of two elements for us as an airline. One is obviously being an airline, and we have very strict goals that we've set ourselves within the airline industry that were set around 10 years ago, when we kind of almost overnight became public enemy number one when it came to emissions, and suddenly this perception that the aviation industry was a big contributor, and not only that, it was a growing contributor, and they weren't actually doing very much to try and reduce their emissions. We were very much caught on the back foot. We didn't kind of expect that kind of backlash for the industry, so we very quickly consolidated and came up with a series of targets, including this 2020 carbon neutral growth, which we're currently kind of grappling with. But back in the UAE, of course, before I even arrived in Abu Dhabi, I'd heard about the fact that Abu Dhabi and the UAE was wanting to be a leader in renewable energy, and the kind of whole world took a step back and thought, why would an oil-dependent country want to do that, and how are they going to approach that goal? And I think that if it wasn't for that, and the fact that Masdar was set up and you know, as a mechanism to help achieve that, I don't actually think when I came into Etihad that I'd have said, right, this is what I really want to do. I mean, I came in thinking we've got to look at biofuels. I knew that biofuels was going to have to be part of the solution to the problem for the aviation industry. I was extremely pleased when, not long after having been at Etihad, I got a knock on the door from Boeing and Masdar saying, please can we have a meeting about collaborating on an alternative fuels program. I thought this is absolutely perfect, because we have the pressure from the industry, we have the kind of pressure, I guess, as a big organisation and a growing organisation within the UAE, and the need to support this renewable energy goal. So it really came at the right time. And I think it's also worth mentioning when it comes to kind of sustainability. I think we were kind of fortunate as within aviation not having been a kind of leader in this, because it meant that we didn't get the backlash that the first generation biofuels got, that were kind of primarily used in things like the road transport industry. The difference with us and other vehicles for using alternative fuels is that we made the decision very early on that we couldn't have we couldn't end up in a situation where we had to modify our aircraft in any way. We couldn't have the luxury of having some of our aircraft that could use one type of fuel and some another. We had to maintain that complete flexibility. So if somebody takes a flight into the UAE, we have biofuel available. They can put it on in their aircraft, and even if they have half a tank still full of regular fuel. So I think this is something that Darren once said, and I use frequently, is that for us it's not an alternative fuel, it's an alternative way of making the same fuel. We have to start with a different feedstock. We have to take it through a technology pathway. We have to end up with jet fuel specification fuel that we can use in the same way as we go out buying from many different oil companies around the world when we pick up fuel. So we were kind of fortunate in that, you know, we were able to stick with very strict sustainability principles. Like, we're one of between 20 and 30 airlines now that are part of the Sustainable Aviation Fuel Use Group. They account for over 30% of the global commercial fuel demand. And we've come together, we've developed a very strict set of principles around sustainability. and we're able to adhere to those still, and we're still very cautious about it and making sure that whatever path we go along, that these principles are not compromised in any way.
So we've heard now from our panelists a few different perspectives. I'd like to open the floor to the audience. If you have any questions you'd like to ask our panelists, please just raise your hand and we'll find a microphone and we'll let you ask the panelists of your choice. A question in the front row, please.
Hello, it's Andrew Doyle from Fly Global here. Just curious what the panel think about the electric taxiing concept. Obviously, EasyJet recently said it was working on a project where they believe by adding about 700 kilograms of weight to each aircraft with this electric taxiing system and the fuel cell that's required to power it, they think they can save about 4% of their fuel consumption, or 50,000 tons per year. Has Etihad, for example, looked at electric taxi? I'm also interested to know what David thinks about that concept. Thanks.
Well, you know, from a system standpoint, obviously it's an aircraft level trade. I mean, there's certain, obviously, efficiencies or savings from doing that. You don't have to start up the engine. You don't have to burn fuel when you're doing that. So there's a significant savings that goes along with that. On the other hand, you're adding some more equipment to the aircraft, and so there's a financial trade that goes on there that the airframers are looking at. I know that Boeing and Airbus and others are looking at those kinds of architectures and trades. Just like, you know, they continue to make advancements. We talked about the implementation of more electric architectures on aircraft, and I think that's another one that's being looked at. You know, they're moving now toward electric brakes and things of that sort. So it's certainly possible with advancements in technology and possibly with more efficient solar panels and cells. I could see it trading successfully in the future.
I think for Etihad, I'd be very surprised if our technical innovation team haven't looked at it, because they're continually looking at options, and I would say that, like any savvy airline, we're completely open to ideas and suggestions. If you're talking about a fraction of a percent of fuel saving, they'll be looking at those options very carefully.
It's also a very interesting question you brought up. It's a fuel cell technology chosen to provide electrical power. So with all the trend on battery, why would the drive be toward the fuel cell for that particular application? So I think there's a competition then, of course, now with these different technologies, what would be the most relevant for even on-ground transportation purposes. So I think that was an interesting thing when I saw that article. I wasn't quite clear on that. So an evolution of technology, who would be the winner now? Fuel cells competing against batteries. Other questions in the audience in the back?
Sorry, awkward seating. Andrew Horter from Aviation Business Magazine. We see car manufacturers pushing low emissions in their adverts these days, whereas airlines still seem to be more on either cost or on service provided. With the environment becoming a bigger issue for society as a whole, do we think lower emissions might become a sales tool for airlines themselves when they're putting their message across to the potential customers?
I think we're seeing that already. I know a lot of airlines in the world are particularly proud of some of the investments they've made in new, more fuel-efficient aircraft, next-generation aircraft. I know Lufthansa is one of them, for example, who's flying the new, again, the Airbus A320neo with our new geared turbofan engine. I think they've been very proud of the fact that it has a much lower carbon footprint, some of the statistics I mentioned earlier compared to previous generations aircraft. So I think they are starting to make a big deal out of the sustainability benefits that comes along with some of the fuel savings. But what's interesting or unique about the airline business is that the sustainability objectives and the financial objectives are perfectly aligned. One of the biggest operating costs of any airline, certainly back when fuel was $100 a barrel, but even today, it's the largest element of cash operating costs of any airline is fuel. And the engine manufacturers and the airframe manufacturers and airlines will work very hard just to get a 1% improvement in fuel efficiency because of the leverage, you know, some of the numbers I talked to earlier in terms of the fuel savings, the lower carbon footprint. So the result of all that is even without really environmental regulation, you've seen an enormous improvement in the fuel efficiency of aircraft. If you go back to the early 60s when jet aircraft were first introduced to today, there's been about a 70% improvement in fuel efficiency. And obviously with every percent improvement in fuel efficiency, reduce the carbon emissions by 1% as well. So there's been enormous improvements in fuel efficiency. If you do the math, it's about 1.5% fuel efficiency improvement a year, typically marked by some kind of step change in engine architectures. You know, when they went from props to jet engines to bypass engines to ultra-high bypass engines, and now with introduction of geared architectures or geared engines in the marketplace, typically you get a step change improvement in fuel efficiencies, followed by maybe a decade or so of incremental 1 or 1.5% type of improvements every year. So that they are doing a lot. They are making enormous strides in terms of the lessening the environmental footprint of aircraft, air transportation today. And again, what's interesting is the sustainability objectives and the financial objectives of the airlines are perfectly aligned, so it really works well. And it's important to people today. It's important to you, it's important to me, it's important to my children or grandchildren. You know, we all want to talk about the fact that we're working hard and making progress at reducing our carbon footprint here. And we are really making progress.
John?
Probably from an air traffic control perspective and the traveling public, you know, we have to admit that air traffic control is a little like plumbing. You can't see it. If we're honest, nobody really understands how it works, but as long as it works, we don't care. So the traveling public don't really think about is the air traffic service provider being as, you know, environmentally friendly as possible. However, it's actually very, very important to our staff, just to echo David's point about, you know, what the groundswell of opinion around this. So it's very important to our staff that we're doing the right thing and that we are making a big effort. And it is very, very important to our airline customers who are, you know, assessing our performance and agreeing our targets. So I think over time that will at some stage pass on to the travelling public, but we've got a bit of, as a Cinderella service, we've got a little bit of work to go before people understand.
Questions for the audience?
So my question relates to alternative sources of energy. And are we missing part of the discussion with respect to the environmental impact by not talking about, or not bringing into the discussion today, disposing of fuel cells, for instance?
That's an interesting question. So we have these environmental technologies which we want to deploy for environmentally friendly behavior within the airline, but is there some life cycle cost environmentally to these technologies? I don't know if any of the particular panelists would like to try and tackle that question.
Again, my perspective, I think the technical hurdles with trying to employ either electric power or solar cells or fuel cells or some of the alternate technologies are just so enormous. Even if you included in trade studies the cost of disposal of some of these things, I don't think it trades out, it doesn't trade favorably. I think we are starting to get to the point, and a lot of it again hinges on what the price of fuel is, whether it's, you know, $100 a barrel or where it is today. You know, I think where the near-term progress and benefit in terms of further reductions in the environmental footprint are going to come from the 3 areas we've talked about. Improved efficiency of aircraft and engines using mechanical propulsion as we know it today, conventional engines as we know them today, the use of more advanced air traffic control systems, and then the third element, biofuel. And that's, I think, where you're going to see progress. And I mean, effectively, biofuel is a form of solar power. I mean, the sun shines, you grow plants, you take the plants, and wonderful chemists like our moderator here figure out ways to turn plants and organic matter into fuel. We've gotten pretty good at doing that. It's now an economic trade, and because fuel is so expensive right now, and we've got a big capital investment to put in to try to build plants to manufacture fuel from biomass. There's a capital investment there, just like with automobiles. Even though electric may trade favorably, there's a huge capital investment to get rid of all the gas stations, refineries, and everything else, and tankers, all the infrastructure that's in there to make petroleum and gasoline, and replace that with charging stations and things of that sort. You've got the same kind of hurdle, I think, with the use of biofuels. Even though they're starting to come to the point where we're making progress, they're becoming more efficient, they certainly trade favorably from a carbon footprint standpoint, but there's, you know, an economic hurdle that we have to get past. And certainly as someday when oil goes back up to $100 a barrel or more, you're going to start to see, I think the numbers that were quoted by Boeing this morning is that I think this year about 1% of the aircraft fuel that was used was biofuel, 1%. I think you'll see that number grow.
Are there questions from the audience? Okay. We're coming close to the end, so I would like to give the panelists a chance to give a very quick response to one final question. We'll just go around. And the question is really, we've been talking about a number of ways to reduce carbon footprint and promote environmental sustainability. We've looked at evolution or advancements in technologies which are on aircraft today, the propulsion system, look at operational measures, and now with bioenergy. The question is, what is really driving environmental technologies in the industry? Is it about the sustainability? Is it about climate change? Is it about COP21? Or is it about something different, the pure economics? So from each of your perspectives, what is the driver? What is really pushing the industry forward in this direction? Start with David.
Well, as I said earlier, I think the driver is both the economics, but it's also, I think, increasingly, to the question that was asked earlier, is sustainability argument. You know, I think all of us are feeling increasing pressure to be innovative and find ways to reduce our carbon footprint. We need to do that for the future generations and for the planet that we live on. So I think you're seeing increasing pressure, but again, it's not something that we all of a sudden have to wake up and start finding a way to work on. We've been doing this consistently year over year, 1.5% a year, improving the fuel efficiency of aircraft and engines, and again, with each % improvement in fuel efficiency, you reduce the carbon footprint of that airplane by 1%. So again, the economic pressure and the sustainability arguments or pressure are perfectly aligned, and I think the more and more as we go forward, the sustainability arguments are going to continue to apply more and more pressure. Now you're starting to finally see regulation with some of the laws and policies and regulations that are being considered by ICAO right now, that they're in the process of finalizing to give us maybe a little bit even more incentive to start driving greater fuel efficiencies with aircraft and engines. But clearly the pressure is there from both an economic and a sustainability standpoint.
Probably just a slightly different slant on it. I think the sustainability argument points to what's the right thing to do, but progress for me seems to be driven by the economic arguments. I think everyone accepts that, you know, that we have to address the sustainability issue, but unless there is either economic benefits in terms of savings, or if it's in a regulatory environment, penalties, I think it really needs that to make some progress, rather than people just saying, you know, it's the right thing to do, we should get right to fixing that.
Darren, any reflections on this question?
Sure. I'll talk to the bioenergy piece, touching on a little bit about what David alluded to or mentioned. Two mega trends going in different directions. Fossil fuels, you know, notwithstanding the relatively inexpensive fossil fuels that are in this part of the world, at least cost of extraction, et cetera. The trend on fossil fuels is they're getting harder to get, notwithstanding the fact that right now, because of the above ground issues going on in the world, it's really cheap. The cost to get it is going up, not down. That's inexorable. The other trend we see and are helping to drive with our friends in the industry and outside the industry, very far outside our industry, is that on the biogenic side, there are fundamental breakthroughs in science that are nonlinear in their ability to reduce costs. That's why, for instance, that 1% of aviation fuel, that's why that's happening this year, is because that tranche of fuel, that pathway through new technologies, those fuels are cost competitive. In fact, in some cases cheaper than petroleum jet fuel today. This is one pathway. So we see that as a megatrend. I think you guys see that as a megatrend. Others do. And that's not, aviation's not driving that megatrend on biogenic fuels and the technologies that relate to things far outside aviation. But what we're trying to do is get as much of that technology directed towards helping us solve our problem. That's something very not traditional within aviation. Typically, aviation hasn't really dealt with things like agriculture and biology and all of the things that relate to these new fuel supplies. But the good news is those technologies are coming along very, very well, and that's driving cost curves down in non-linear ways for these new biological technologies, for biocommodities, including fuel. That's a big deal, and it's new and it's disruptive, and that's something that we are glad to have happening right now, especially.
Lyndon, finally with you. Closing comment.
I mean, it's all about the surety of supply, isn't it? I mean, sorry, not the surety of supply, that was the Darren mentioned, about the license to grow, sorry, I meant to say. The license to grow is obviously very important for us as the airline. There's a lot of pressure on us to reduce our carbon emissions. We don't want to see the plethora of regulations that could replicate what's going on in Europe right now, which is very much why the industry is supportive of this global measure that we alluded to, this global market-based measure that ICAO is working on. We've seen pretty much all of the industry has kind of come together on this and said, look, this could be the best option for us compared to every state around the world coming out with different rules and regulations on how they're going to somehow impose costs, charges, taxes on the aviation industry. I mean, this is basically being used as an excuse in a lot of places. The emissions associated with aviation, they're finding some way to use that as a means of getting income. We want to make sure there's a global measure. So I think a lot of it is, in terms of what is kind of driving this, it's the fact that we need to have this global measure. So we're going in the direction and I hope that that's what we'll achieve.
Thank you. Well, this is some very interesting reflections we had on this overall topic, and we're now at the end of the time. I'd just like to close by saying, just reflecting back on this question about introducing environmental technology into commercial aviation, it's clear that technologies are being introduced today, and we see propulsion systems making rapid advancements, definitely with tremendous amounts of fuel efficiency savings, and really going to continue to evolve into the future. And so these technologies will be leading into that generation of biofuels, which Darren said, it's nascent, but it's happening. And with strong support from airlines like Etihad Airways, looking very closely at the regulations, knowing how this is going to affect their core business, it's going to pool these new technologies that need to evolve from the nascent state into the fully commercially viable state forward, so that in the next coming years, we'll see Etihad, for instance, as you said, using routinely in their flights the aviation biofuels, which would be great, at least in a blended mix. And then on the operational side, again, we're seeing things happen today. It's not about technology per se, besides perhaps the software systems you're using, which, as you reflected, you don't really know how they all work, but they work, and as long as they work, you're happy. It's about a system of knowing that we need to look at real-time management of airspace, have air traffic control, and have these operational measures, which all the roadmaps of industry say are necessary and essential to get to the point we want to lowering those carbon emissions by 2050, to the point where we're seeing that those measures looked at from the COP21 and these environmental sustainability perspectives globally will be achieved. So with that, I close. Thank you for staying this late and appreciate your time. One nice hand for our distinguished panelists. Thank you very much.
Stephen, thanks very much.